Hi all, this is Alan Tao with Bothwell STEM Coach, and today we're continuing on, or we're looking at the AP Physics C free response questions for mechanics from the 2019 exam. Interestingly enough, the College Board put out 2 sets of free response questions, so I'm curious which ones you guys got if there were different tests, but I'm going to do solutions to both of them. I have actually put together solutions already for all sets of mechanics and E&M free response questions. You can find that in the description below, and those will be corrected in case I made any mistakes. I try my best to get them right the first time, but if I make any mistakes, I'll have corrections in the description below, and the PDFs will have the exact solutions too. In an experiment, students use video analysis to track the motion of an object falling vertically through a fluid in glass cylinder. The object of mass 12 grams released atop the column fluid. The data for the speed of the falling object's function time is graphed on the grid below, and the dash curve represents the best fit chosen by students for this data. Okay, so we have this data of velocity versus time. So basically it's going to fall and it's going to go faster and faster as it falls down, right, as it sinks. Does the speed of the object increase, decrease, or remain the same? Clearly it's getting faster. V is going up, so it's getting faster. Increase. In a brief statement, describe the direction of the object's acceleration, how the magnitude of this acceleration changed as the object fell. The object accelerated, let's see, well, it's, the acceleration's down because the object is falling, okay, and it's speeding up while it's going down, right? The velocity is getting more and more bigger and bigger. So the acceleration A is downward. And what is the magnitude of the acceleration? How the magnitude of this acceleration changed as the object fell? The acceleration is the slope, and it decreases as it fell, right? So the acceleration is the slope of these lines, and it went down. So, and the decreased over time. It decreased over time. Or decreased as t progressed, basically, and the reason is because the slopes get more and more flat, right? Using the graph, calculate the approximate value for the magnitude of the acceleration of the object at t equals 0.2 seconds. So 0.2 seconds, I'm doing the slope here. I will attempt to draw a good line. Let's see. So say I wanted to draw a line like, oh, that's pretty good. You know, not exact, but, you know, you would try to sketch that better. And good. So I want the slope of this point right here. So what's the slope look like? Let's pick a point, say here. Say that point is 0.8. So 0.25 comma let's see, is 0.85. And let's say the point here, for example, is 0.15, and the y value we'll say is 0.6, is 0.65, we'll pay 0.63 or something like that. And so the slope would be 0.85 minus 0.63 over 0.25 minus 0.15. So I would get 2.2 meters per second squared, about. So 2.2 meters per second squared. Students use this equation to model the speed of the falling object and find the best fit coefficients to be A and B is that. Use the above equation to determine the expression of the magnitude of the vertical displacement of the falling object as a function of time. So in general, y of t is going to be the integral of velocity. So if I do the integral of this, it's going to be A is a constant. The integral of 1 is t. The integral of this is e to the negative bt divided by negative b, so it's plus 1 over b e to the negative bt plus a constant. And the magnitude of the vertical displacement. So we would probably want to say that the vertical displacement at 0 is equal to 0. And so we would say, well, this is, to find this constant, I would a times 0 plus 1 over b e to the 0 plus c is equal to 0. This is 0, e to the 0 is 1, so this is a over b plus c is equal to 0. So c would equal negative a over b, and so y of t would then equal this. A times t plus 1 over b e to the negative bt minus a over b. And if they really wanted you to put in numbers for all of those, that would be kind of annoying, but you could. That's the general expression. F of t is equal to mass times the acceleration. That's the net force, right? And acceleration is the derivative of velocity. So that's m times the derivative of velocity would be, the derivative of 1 is 0. The derivative of this would be a times b e to the negative bt. So that would be the force. Okay. Students repeat the experiment with a taller glass cylinder that is filled with the same fluid. The cylinder is tall enough so the object reaches a constant speed. Determine the speed of that object. It's just what happens to the velocity as t goes to infinity. And the limit as t goes to infinity, e to the negative, so b is a positive number. E to the negative positive number times t is just e to the negative infinity. That's like 0. So it just approaches a. So v would equal a, which would equal 1.18 meters per second. Determine the force exerted by the fluid on the object at this time. That would be what happens as t goes to infinity here. Oh, actually, no. The net force. So this tells you that the net force will be 0. Right? But this object doesn't have a net force. There's a force on gravity and then a force on the fluid, we'll say. It's probably drag or whatever. Probably drag or buoyancy. I don't know. Kind of just say it's some force that's going up. And that, if the net force is 0 because the acceleration is 0, these forces have to be equal. So the force on the fluid would equal Fg, which would equal mg. And m was 0.012 kilograms because it was 12 grams times 9.8 meters per second squared. And I get 0.012 times 9.8, and I get 0.1176 newtons. Okay. Oh, and that was number 1. So hope you found that helpful. Let me know how you did, and let me know which set of questions that you ended up getting. And I'll see you in the next question.